Hello and Assalamualaikum everyone. Welcome to MSG 453 Queuing System and Simulation Lecture 1. Okay, so this lecture will cover the basic concepts and terminology for queuing systems. So we will look first at the history and background of queuing theory, and then we will move on to the characteristic of queuing process. Next, we will have a look at the types of queuing systems, and finally, we will move on to notation and terminology often used in queuing system. So the study of queuing theory originates back in the early 1900s when the problem related to telephone traffic congestions was studied by A.K. Erlang. Okay, so basically he pioneered the study on queuing theory that have gained more interest ever since. Okay, so what is queuing theory all about? What is it about? Okay, so queuing theory basically is a mathematical analysis of queue or waiting line. So we encounter this problem on a daily basis where we have to wait in queue before we receive a certain service that we need. Okay, so the theory was developed, okay, in order to provide models to predict the behavior of systems, okay, that attempt to provide the service for a certain demand. Okay, we will use queuing models to represent various type of queuing system. Okay, so basically it involves, okay, it represent the system where customer, okay, you have a customer, also can be known as a job or task, not necessarily human being. So this customer arrives into the system seeking some kind of service from the server, okay, and then it will depart the system once it has finished receiving the service that it required. Okay, so an example of queuing systems and also the customer and server in the system, okay, can be one of it. The simplest example could be the hospital, okay, where your customer can be represented by a patient and the server that will attend to the customer can be represented by a doctor or nurse. Okay, so another simple example would be when we go to supermarket to buy our daily necessity. Okay, so we have to wait when we want to pay for our item. Okay, the server would be the cashier at the checkout counter. We are the customer and the system is the supermarket. Okay, an example of a non-human being customer could be a car or computer, okay, where the system is for car, the system can be a road, and the server is the traffic light because the car have to form a queue while waiting for the traffic light to go green. Okay, so we encounter this basically on our daily life, right? So why actually we have to wait? Why is that such a situation occur? Why is there waiting line? So the simplest explanation would be because there are more demand than the service facilities available to serve the customer. Okay, so this situation occur could be because multiple of reason, but some of it could be because of resource shortage. Okay, and also it is economically infeasible to, let's say, hire more server, okay, to attend the customer, and also it could be due to space limitation of the system. Okay, if you have a smaller space for the system, okay, so you have a smaller space to locate your server, and that's why your customer have to wait before receiving the service. Okay, so the aims of queuing analysis basically revolves around three things. First, we want to look at the time. The second, we want to look at the behavior of the customer, and then we want to look at the behavior or we want to analyze based on the server. So with regards to time, okay, so basically we want to know, to put it in simpler terms, we want to know how long that we have to wait until we receive the service. And also it could be how long that we will spend in the system before we can leave. Okay, so for example, how long you have to go to the bank, wait in line, and finally you can leave the bank. Okay, so with regards to customer, we might be interested to know how many person waiting in the line per hour or maybe per minute in a certain system. Okay, so finally, okay, with respect to the server, we might be interested to know what is the proportion of time that the server is busy, what is the proportion of time that the server have no customer to serve, or also known as when the server is idle, okay, not having any customer to serve. Okay, and also we can analyze what happened if we increase or decrease the number of the server, how it will affect the system itself and how it will affect the time that the customer have to spend waiting in the queue. Okay, so this study or analysis is important in order to predict various characteristics of waiting line or queue to provide an important information to decision maker or researcher. Okay, so next we will move on to characteristics of queuing process. So most queuing model assume the basic queuing process where the customer that requires service are generated by calling population. Calling population basically represents your potential customer or customer that might require service. Okay, so the customer that requires service will be generated by the calling population, and these customers will then enter the queuing system here and join the queue waiting for the service. Okay, so after a certain waiting time, so the member of the queue is selected to receive the service based on the queue discipline. Right, so the required service is performed by the service mechanism here. Okay, the service mechanism consists of the server and also the service channel. Okay, so after the server has completed the service process for the customer will then depart and leaves the system. So this departure is basically the outcome of arrival, waiting, and also service process. Okay, so there are many types of queuing process. So one process is differentiated from another based on 6 factors. Okay, so the first factor is the calling population. The second factor is the arrival pattern of the customer. The third factor would be the service pattern here. Okay, it involves on the service time as well. Okay, so the fourth factor is the system capacity, the maximum number of customers allowed to wait in the queue. So the fifth factor is the queue discipline. Okay, depends on the order of the customer that will receive the service. Okay, and then finally on the final characteristic is about or on the service mechanism comprised of the server and also the service channel. Okay, so basically factors 2, 3, 4, 5, and 6 will provide an adequate description of the queuing systems depending or based on factor number 1. Okay, so we're going to look at each factor one by one. So factor number 1 is calling population or input source or your potential customer. Okay, so the size of your calling population can either be finite or infinite. Okay, for finite calling population, the number of customer in the queuing system will affect the potential customer outside the system. So for example, you have 10 potential customer, which is a finite number of calling population. So let's say there's already 2 customer in the queuing system. Okay, so the balance in your calling population is only 8 customer. So this number or situation of finite calling population will affect the potential or the arrival of the customer into the system. Okay, so for infinite calling population, so the number of customer in the queuing system basically does not affect the potential customer outside the system or your calling population. Okay, moving on to our second characteristics is on the arrival pattern of customers. So basically these are measured in terms of average number of arrival per hour or average time between successive arrival. So when we're talking about average number of arrival, this is with regards to the customer. So basically it is a discrete process. So for example, on average, 3 customers arrive every 1 hour. So 3 customers per hour. Okay, so when we're talking about the average time between successive arrivals, so this is basically a continuous process because we're looking at the time between each arrival. Okay, so on average, the time between one arrival, let's say first arrival and the next arrival, is 20 minutes. Okay, so we're looking at the time here, so this is a continuous process. Okay, so the arrival process can either be deterministic, random, batch, or type arrival. Okay, so for deterministic arrival, okay, so it considers a constant time interval between successive arrival. For example, you have the time between your first arrival and second arrival is 1. It's a constant. Okay, it's 1, and then your second arrival and third arrival is also 1 with respect to time. Okay, so the second type of arrival is a random arrival. It can either be probabilistic or stochastic, where the time between each successive arrival is different or random. Okay, so from 0 arrival, you don't have any customer up until your first arrival. Okay, the time between this arrival is T1. Okay, the time between first arrival and second arrival is T2, and so on. Okay, the third type of arrival process is batch arrival. Okay, so for batch arrival, okay, so each arrival arrives in batch. For example, the first arrival, you have 4 customers, the first batch of arrival, and the second batch of arrival, you have 2 customers, and so on. Okay, the TI here can either be deterministic or random. Okay, so finally, type the arrival process. Okay, the type arrival basically means different types of arrival requiring different types of service. Usually, the queuing situations, the process of arrivals is a stochastic process. So when it is a stochastic process of arrival, it is necessary for us to know the probability distribution of the inter-arrival time, okay, which is the time between each successive arrival. Okay, apart from that, it is also necessary for us to consider the reaction of the customer before entering the system and after the customer have entered the system. So 3 possible reactions are known as bulking, reneging, and jockeying. So for bulking, so basically the customer did not even enter the system. Okay, the customer see there are no more waiting space in the queue, or maybe because the waiting line is too long, so the customer decides not to enter the system at all. Okay, for example, if you have a small shop, okay, the waiting line or queue inside the shop is already full. Okay, the customer saw from outside the shop and then decided not to enter the shop, hence meaning the customer did not even enter the system. The customer did not even arrive in the system. Okay, so the second type of reaction is reneging. So the customer did enter the system by joining the queue, okay, but after some times the customer might lost patience because of waiting too long, or maybe the customer have some other things to do and cannot wait anymore. The customer decides to leave the waiting line, thus leaving the queuing system. okay, the customer can return. Okay, the same goes with bulking. Okay, the customer can return, so the same as this one. But usually when the customer renege, so after waiting too long, the customer wouldn't want to return. Okay, but might return later once the waiting line have become shorter, right? So the third reaction of the customer is called jockeying. So this situation will happen if you have parallel waiting line, where the customer will jump from one line to another. So the customer stays in the system. So for example, at the supermarket checkout counter, so the customer already enter line number 1 at the checkout counter number 1, and then see suddenly the checkout counter number 3 is moving faster, so the customer jockey to another line. Okay, so this is what we call as jockeying. So renege and jockeying when the customer is already in the system, but bulking basically means the customer did not enter the system, decides not to enter because there are no more space or the waiting line is too long. Okay, so one final factor to be considered regarding the arrival pattern is the manner in which the pattern change with time, whether it is time independent or time dependent. Okay, so an arrival pattern that does not change with time or time independent is called a stationary arrival pattern. For example, 10 customers per hour for the whole day or whole opening hours of a shop, for example. Okay, and the time dependent, okay, for time dependent arrival pattern is known as non-stationary arrival pattern. Okay, it is time dependent or seasonal. For example, 30 customers during peak hour or lunch hour and 10 customers during normal hour. Okay, so that is on our second characteristic, which is the arrival pattern of customer. So moving on to our third characteristics is on the service pattern. So it is similar to arrival pattern, but arrival pattern is a pattern concerning the behavior of the customer. But the service pattern is on the behavior or situation of the server in the service mechanism itself. Okay, so it is measured in terms of average number of customers served per unit of time or average time required to service a customer, right? So characteristic number 4 is on the system capacity. So system capacity represents the maximum number of customers allowed to wait in a queue. There are two possible situations. The first one is finite queue, where you have limited waiting space, where customer that arrives when the queue is full cannot even enter the system. So the second one is infinite queue, unlimited waiting space, so the queue can just grow longer and longer without any limitation. Okay. So factor number 5 is the queue disciplines. So queue disciplines refer to the disciplines or order in which members of the queue are selected for service. So these are the most common queue discipline. So the first one is first in, first out, also known as first come, first serve. Okay, so usually some of the example of a FIFO discipline is supermarket checkout, petrol station, and also a barber shop. Okay, the second type of queue discipline would be last in, first out. Okay, for example, stack of files, so the last one stack up will be read first, and also it can be in inventory system. Okay, the third type of queue discipline would be service in random order. For example, you have a batch of product waiting for quality control, so basically it will be checked based on random order. Okay, it is not arranged anything, so the quality control, the person in charge of the quality control will just take whichever is closer to them without knowing which product is completed first. Okay, so finally is a priority queue discipline. So there are two types of priority queue discipline. The first one is preemptive and the second one is non-preemptive. So for preemptive priority discipline, the customer with highest priority is allowed to enter the service immediately, even though currently the server is serving another customer. Okay, so for non-preemptive, the customer with highest priority just go to the head of the queue, but have to wait until the current customer served by the server completed its service process. Okay, so those are the difference. So for preemptive, okay, the server will sort of abandon the current customer it served to entertain the customer with highest priority. But for non-preemptive, the customer with highest priority will only go to the head of the queue, but have to wait until the server completed providing service to its current customer, right? So finally is our final characteristic of queuing process is on the service mechanism. So it consists of one or more service facilities where each of the facilities or channel, okay, where each of the facilities contains one or more parallel service channels called server. Okay. A queuing model basically must specify the arrangement of the facilities and number of server. Okay, so example of channel is how many service channel is in the system. So for example, for medical checkup, okay, your channel number 1, you have registration, and then you have to go to measure your weight and height, and then you have to go and take your blood sample, and then you have to go and do your x-ray, and then finally consultation with the doctor. Okay, example of a server is how many server available at each of the service channel. Okay, so for medical checkup, for example, for channel 1 registration, you have 3 counters. Okay, for channel 2, you have 2 nurses to measure the weight and height of the patient or your customer, and so on. Okay, so that is on the service mechanism. Okay, so those are the 6 characteristics of queuing process that differentiate one model from another. Okay, so next we will move on to look at the types of queuing systems. So there are several types, and we're going to discuss a few types of queuing systems. Okay, the first one would be the elementary queuing system. Okay, the one in figure 1.2 is where you have multiple server, but it can also be you only have a single server in your elementary queuing system. It's either one server or multiple server here. Okay, you just have one line and then sort of one server providing the service. You have one waiting line. Okay, so next would be the multi-channel, or we can say it is a parallel queuing system. Okay, where you have multiple waiting lines waiting for multiple servers. So this is where an example of jockeying can happen. Okay, if all of the server provide same service, so jockeying can happen here. Okay, so next is a multi-stage queuing system. Okay, where the customer needs to enter and receive service from multiple server in order to complete the process. Okay, so next would be cyclic queue in figure 1.5. Okay, for example, this would be usually a production in a factory, okay, like on a conveyor belt or something, where the product needs to go through a cyclic queue. Okay, and then finally a network queue. Okay, the customer have to line up, okay, go to the server and then go to another server, okay, depending on the service that the customer needs to receive. Okay, so those are several types of queuing system. Okay, there are also other types as well, but we're going to just discuss these 5 types of queuing systems. Okay, and then finally we're going to move on to the notation, the standard notation and terminology usually used in queuing system. Okay, so this notation, okay, evolved due to the work of Kendall in 1953. So Kendall proposed describing queuing process using 3 factors. but then it has been extended, and now it is often described by series of symbols and slashes. You will have symbols and slashes. Okay, so these are the common used notation. So where A represents the inter-arrival time distribution and B represent the service time distribution. So X represent the number of parallel servers, and Y is the restriction on system capacity, and Z is your queue discipline. Okay, so for example, if you have M, D to infinity and FIFO, it means it indicates a queuing process with exponential inter-arrival times, deterministic service times. You have two parallel servers and no restriction on the maximum number allowed in the system, and it has a first in first out queue discipline. Okay, you can refer to table 1.1 for more information on the notation, right? So usually, okay, so in many practice, okay, if your Y or your system capacity is equals to infinity, basically you don't have any restriction on the system capacity or waiting line. Okay, so we will just omit this particular symbol. And also when your Z or your Q discipline is equals to FIFO. Okay, so if your Y is equals to infinity and your Z is equals to first in first out, we usually are left with only 3 of the symbol. Okay, for example, you have MD2. Okay, so we know that it is with infinity system capacity, and also it practice the Q discipline of FIFO, right? So let us look at one example, okay, where we want to discuss the calling population, queue discipline, and also the service mechanism of the following queuing system. So the first example is supermarket checkout counter. Okay, so let us discuss the calling population, queue discipline, and also service mechanism. Okay, so for example, at the supermarket checkout counter, so the calling population would be customer inside the supermarket, not necessarily the customer have to buy stuff. Sometimes they just enter and then browse through, but they are the potential customer. They will enter the system if they buy something and they want to pay. Okay, the queue disciplines usually is first in first out, where you have to line out at the checkout counter. Okay, and the service mechanism is parallel checkout counter, where you have 1 or 2 server at each of the counter. Okay, so for B, C, and sorry, this should be D. B, C, and D. So you can try and discuss the calling population, queue discipline, and service mechanism. There are no right or wrong answer. Basically, you just need to describe the possible situation at each of the queuing system. Okay, so that is it for lecture 1 introduction for MSG 453. Okay, thank you very much.